Hello everyone, welcome back to my channel Geomatics Engineering. As we have already completed 3 lectures in this course PG Diploma in Geoinformatics, and today we are going to cover the introduction to geospatial data. And as we are following the syllabus, so from block 1 in the overview of Geoinformatics, we have already covered all the 3 units in last 3 lectures. And today from block 2 we are going to cover the unit 4 introduction to geospatial data. So what is going to be the learning outcome from today's lecture? So we will able to define and differentiate between data and information, and we will also define geospatial data and geospatial information, and we will also discuss different kinds of data. So firstly we will know about what is data. So data is derived from a Latin word datum, that means given. So datum is similar to a French word donner. So from there we can know that the data term came up from Latin, and it is the foundation for understanding and explanation. And any kind of data can be represented in digits, letters and symbols, and in so many ways data can be represented. Now next, what is information? So information is fact about something or someone, and when we relate the information with geospatial information, then it is information that describes location and their names of Earth's features. So from this slide you will get a clearer information between data versus information. So data is raw. It is just fact and figures that represent the external world. Like for example, think of a pile of unorganized letters. There are so many letters that are unorganized and kept in a way like a pile of letters. And information is like processed and organized data with meaning and context. Like information is generated from data. So for example, think of a word formed from those letters. Like from this pile of unorganized letter, we organized this pile and created a word from those letters. So from these two definitions, we can say that data is like an ingredient for a cake, like a raw material, and information is like a baked and decorated cake. So information is collected from data, and information is used to organize the data and collect more information from data. And there is also a term precision and accuracy that is also related to data. So what is precision? So precision refers to the repeatability of data. Like when we talk about the precision, then we talk about the consistency, like how consistent measurements are, even if they might be wrong. Like if measurements are consistent, then they are precise, even if they are not accurate. Like imagine throwing darts at a target. Like here in image you can see that the darts throws on a target, and if your darts are all grouped closely together, even if they are not in bullseye, then it is precise. Like here in the first image we can see that all darts are closely placed, so they are precise. And also they are at the center of the dart, so they are also highly accurate. So in some case maybe they are also closely placed on here. So in this case the measurements are precise, but they are far away from the center, so it will be not accurate. And when the darts are not closely placed and also not accurate, then there will be low accuracy and low precision. And the next term is accuracy. So accuracy refers to how close measurements is to the true value. Like from example, if we see this dart, so the true value is our center, and to become the measurements highly accurate, all the darts should be placed near to the true value, then only it can be highly accurate. So in essence we can say that precise data may not be accurate. So for high precision, it is not needed that it should be accurate. Like here in this first and second image, the measurements in the first image are closely and also in the center, so they are precise and also accurate. But in the second measurement, the measurements are closely but away from the true value. So these are all are precise because they are closely placed, but they are away from the center, so these are inaccurate. And in accurate data, it can be both precise and correct, but for higher accuracy it should be close to the true value and consistent. Now we will know about the types of data. So there are several ways to classify the data, like by source, by geospatial reference, and by composition. So by source there are two different kinds of data, primary data and secondary data. So primary data is collected first hand through survey field work. So like the data that is collected from the first place, like surveys go on the field using instruments, they collect the data. So that will be known as primary data. And secondary data that is already collected and available from external sources like published map and statistics. So secondary data is generated from primary data. So by using the primary data, when there are maps created from this or any statistics created from that data, and then these maps and statistics can be used as a secondary data. So these are the two types that are classified within by source. Then we have the second classification, that is by geospatial reference. So there it is also of two types, that is primary geospatial data and secondary geospatial data. So primary geospatial data is same as the primary data, like it is also collected directly with the location information like satellite imagery that is collected on the first place using satellites. And secondary geospatial data is like it is derived from existing maps or data. So it is also just like the secondary data. So by using the primary data, we create maps and do the digitization part and get more information from that primary data. Then these maps are prepared and it can be used as a secondary geospatial data. Now the next type of classification is by composition. So there it is also having two types, the spatial data and non-spatial data. So spatial data means it represents about location. Like for example, we can say that like Taj Mahal. Taj Mahal is in Agra. So we are talking about the location of Taj Mahal. And then the non-spatial data. So non-spatial data talks about the attributes that describe the characteristics of a location, like adding more information to the spatial data. Like we know that Taj Mahal is in Agra from spatial data, and then we will add more information to this data, like Taj Mahal is how far away from Delhi, Taj Mahal is situated in how much of area, what are the nearby locations from Taj Mahal. So when we add more attributes to this location information, then it is known as a non-spatial data. And there are also some additional data types like temporal data, where we talk about the time component, metadata, where we talk about the data itself, measured data, inferred data, imported data. We'll cover about all these data types in upcoming slides one by one. So before that, we will talk some more about spatial data. Like we already know that spatial data refers to any information that has a specific location on the Earth's surface. Like for example, imagine a map that has location of features like rivers and cities, that are spatial data. So for example, of spatial data, that is location of any rain gauge system, the area flooded during a disaster, delivery truck routes, the extent of a forest fire, tourist attractions. So these are kind of example of spatial data. And within the spatial data, we have two types of data, vector data and raster data. So what is vector data? So vector data uses points, lines and polygons to represent any feature or location. So point defines specific location. So for example, like within a map there is a well, so point can define about that well, and line connects point to represent linear feature like road from one location to another location. And polygon defines area with a closed loop of line like lake. So any lake that is having an enclosed boundary, so it can be represented as a polygon. So this is how using point, line and polygon we can represent about any location that falls within a spatial data. So this is all about vector data. And then the raster data, that is also a type of spatial data. So it uses a fixed grid of cells to represent any space like satellite image. So here we are having a satellite image. So whenever you zoomed in within a satellite image or any digital photograph, you can see that it has a grid kind of structure where each cell holds a value that represents its characteristics. Like within this cell is having an information about this location, that what is the elevation of this area, what type of land cover within this cell, and we also known this cell as a pixel. And raster data is suitable for representing the continuous kind of data. Continuous kind of data is like the data that is present everywhere on the earth, like temperature, soil, elevation. These kind of data are continuous data. And raster data type is best data type to represent these kind of data. And vector data is good for representing discrete type of data, like that is not present everywhere on earth, like buildings, roads, lakes, that are not present everywhere on earth. So it can be represented by using vector data. Now we have non-spatial data, that is also known as attribute data, that we already learned about. When we add more information to a spatial data, that is known as a attribute data. Like for example, imagine a map that is having symbols for building. So the spatial data is the location and symbol of the building, and while the non-spatial data describes that what is the building material, what brick type is used in the building, what is the concrete type. So these kind of other information when added to any spatial data, that is known as a non-spatial data. So for example of a non-spatial data, like the material used to construct a building, that falls within a non-spatial data. Type of rain gauge used to measure rainfall, land use types, name of cities and districts. So these kind of information falls within a non-spatial data. So what is the relation of non-spatial data with spatial data? So non-spatial data adds the context and meaning to spatial data. It helps us to understand what the features on a map represent. So for example, think of a map symbol as a person, and spatial data is the person's locations, and the non-spatial data is their name, age, profession is fall within the non-spatial data. And now we will talk about the additional data types. We have already learned about spatial data, non-spatial data, and within spatial we have already learned about vector and raster. And beyond this, there are some more kind of data types like temporal data. So temporal data is like understanding of how things change over the time, like from 2000 to 2024, how things are changed on the earth's surface. So for example, like weather pattern and environmental changes. So over the earth's surface, how the weather and pattern changes over the 20 and 30 years span. Population trends and demography, how the population has been increased within the 30 years, traffic conditions and congestion patterns, monitoring resources use and depletion, land use changes within the years. So when we compare within two time period, like how things have been changed within this time span, so the changes that happens falls under the temporal data. Next type of data is metadata. So metadata is like data about data. So it provides critical information that describe the content, origin, quality and other characteristic of a data. Like think of it as a label on a box. Like here for example, there is a box and over the box there is a label. So just by reading the label we can know that what is inside the box. So that is data about data. So metadata is also of two types, structured metadata and unstructured metadata. So structured metadata is designed for computers to read and process, often uses predefined fields and format. And unstructured metadata is designed for humans to read and understand. It provides context and descriptive information. So there are also some standards of metadata like FGDCCS-DGM, that is Federal Geographic Data Committee. So it is widely used standard that is used in the USA. And ISO 19115, it is an international standard for geographic information metadata, and it is also mostly compatible with Federal Geographic Data Committee. So these are two standard types of metadata. Then next type of data is measured data. So measured data is data that is obtained through direct measurement in the field. Like surveyors going to the field and using the instrument, they collected the data about the length from one location to another location, like any points, elevation. So that is measured data. So it is considered the most reliable source if the measurement process is well understood and documented. So it is also a kind of primary data. So before using measured data, it is important to recheck the information that is collected from field, because even minor errors like incorrect transcription of the field notes, it can compromise the data quality. So what can be the potential sources of error? So instrument limitation, environmental factor, human error during the measurement or recording can be a potential source of error in measured data. Now the next type of data is inferred data. So inferred data is the data that is derived through analysis and calculation based on other existing data. Like it is kind of secondary data, like we already have data, and by analyzing this data we do some calculation and model building and extract some more information is known as inferred data, like inferring crop types in a field based on the electromagnetic radiation it reflects using satellite imagery. It is a type of example for inferred data. And next data type is imported data. It is also known as converted data. So the data that has been brought in from another source and potentially transferred into a compatible format. So as in the name it is mentioned that it is converted data. So we get this data from another source and convert it into another format to extract information from it. So that is imported data. So it is uncommon to use this data solely from one source for decision making. Data from various sources is often combined for a more comprehensive picture. So just for combining data from different sources, we need to convert the format to bring them together on one platform so that we can get more information. So that is kind of imported data. So these are all the types of data within the geospatial. Now we'll summarize about what we have learned from this lecture. So we've learned about the data, that is like what you collect through observation, measurement and interference. Like it is a raw, unorganized type of thing that is known as data. And information is the data presented in an organized form. When we convert the raw data that is in unorganized format into an organized format, so it became an information. And precision in like the data that is related to the repeatability of data obtained, while accuracy is the measurement of data. Like in precision the data must not be accurate, but measurement should be together closely, and in accuracy measurement should be near to the true value. And we have also learned about the categories and classification within the primary and secondary kind of data. And we have also learned about the different kind of data like spatial data, non-spatial data, temporal data, measured data, metadata, inferred data and imported data. And also the data processing is used to create useful information from data, and major stages of data processing are acquisition, retrieval, analysis and presentation, so that we can collect more and more information. So this is all about introduction to geospatial data. I hope you liked this video, and if you are having any queries regarding this lecture, please let me know in the comment section. Thank you very much.